All right, as we progress in our learning about the world around us, after we talk about atoms comes kind of the next biggest thing, and it is called the organizational chart of matter, which sounds big and complicated, and nobody ever knows what that means. In short, what is it? How complex is it? And there are several, 5, I think, different categories where we can place our different types of matter. The first and arguably, we'll say most straightforward of our types of matter is the element. These are the things on the periodic table. And they are composed of but a single type of atom. Now notice, I didn't say single atom, I said single type of atom. So, for example, if you take a brick of gold, atomic symbol Au, if you separate it down into the smallest possible bit that is still identifiable as gold, you would still have gold. It would still have the same properties, same melting point, boiling point, color, reactivity, all of that jazz. It is all, the whole thing is made up of gold atoms. A lot of them, depending on the size of the bar, but they're all gold atoms. Iron bars, once again, it is composed completely and totally of iron atoms. And this is, as I said, the most straightforward, arguably the simplest form of matter. If we take elements and we combine them, we have 2 different ways that we can do that. The first way involves the creation of a compound. This involves a chemical reaction. And what do I mean by that? A chemical reaction is the combination of 2 or more elements in such a way that they cannot be separated physically. This is the technical definition of this is 2 or more elements chemically bound. Chemically bound usually refers to an interaction between the electrons. We talked about atoms. Those outermost electrons will interact in a couple of different ways. And that's what creates that chemical bound. What is a bound? A bond between 2 or more elements, 2 or more atoms. For example, if we take sodium, sodium is a silver white metal. It is soft enough to be cut with a butter knife, has a rather explosive reaction with water, so if you were to put sodium on a tomato, it would explode and make a huge mess. If we react that chemically with chlorine gas. Chlorine is a yellow-green gas, rather toxic, so if you were to sprinkle that on a tomato, you would probably have zombified, gross-looking tomato. Rather scary. Again, not good for the eating. If I take these 2 very different elements, each with their own set of properties, and I put them together in a flask, it undergoes a rather spectacular exothermic reaction. Lots of sparks and fire and smoke and heat. And they will combine into something called sodium chloride, NaCl, aka table salt. The Na and the Cl are now bound together. I cannot separate them physically. I cannot pull them apart. If I had tweezers small enough to get down to atomic size, I could not pull these apart. They are stuck together. It would take another chemical reaction, so talking about interacting electrons again here, in order to separate those 2. So, this guy blows up when I put it on the tomato. This guy, toxic, deadly, don't want to put it on the tomato. This guy, rather tasty. Now, in large amounts, still not good for your heart, but I can have a little bit of salt and pepper on my tomato, should I so desire. It's a white crystal, very high melting point. Again, rather tasty on food. So we go from explosive, toxic, to edible. So your new compound usually has absolutely nothing in common with your original elements. And this is one way that I can combine these 2 or more elements. The other way is called a mixture, and you are well familiar with mixtures. Mixtures, you take things, you stir. There is no chemical reaction involved. This is a physical combination. which means I can use physical means to separate them. For example, salt and water. If you were to dissolve salt in water, you can't see the pieces anymore. Looks like it's some kind of chemical reaction. But if I wanted to, I could separate the salt from the water once again by boiling, using the property of boiling point to separate those two. Chex Mix is a mixture. Your Chex and your M&Ms are physically combined. I could separate them rather easily, in fact. The mixtures have a couple of different types, a couple of different names that we can have. The first is a homogeneous mixture. Homo means same. And so this is a mixture in which you cannot see the bits and pieces. So things like, as I said, salt water. Things like soda before you open it, so you can't see any bubbles yet. Things like Kool-Aid are all homogeneous mixtures. I cannot see the bits and pieces. The air around you is a mixture of nitrogen, oxygen, carbon dioxide, a little bit of water vapor, maybe a dash of argon in there. But again, can't see the bits and pieces. The flip side of that is a heterogeneous mixture. And a heterogeneous mixture is one in which I can see the bits and pieces. Think pizza, Italian salad dressing, Chex Mix. Sand is actually a heterogeneous mixture, as you can see all of the bits and pieces. But again, these are mixtures, meaning they can be separated by physical means. A couple of more types of mixtures that I just wanted to mention. Bring your attention to the fact that they exist. The first is a colloid or a suspension, where you have larger particles that are perhaps suspended in a liquid. Things like Jell-O. Things like, I can't even, fog, where the particles seem to hang. The last one, the solution, is the one I particularly want to draw your attention to because we have an entire section in my chemistry class called solutions. And solutions is when you have one thing dissolved into another. And these are usually homogeneous, mixtures, meaning I can separate them back into their original constituent parts. Might be kind of tricky, but I can do it. So, salt in water, that is a solution. The salt dissolves into the water. Kool-Aid, again, that is a solution. We can put two liquids together in a solution. Antifreeze is a mixture of ethylene glycol and water. The alcohol, the grain alcohol, the vodka that you buy on the shelf, that bottle of vodka is not 100% ethanol. You would be dead faster than you can blink. But instead is usually a mixture of ethanol and water a lot of times. Let's see, anything else? The two gases together is called a solution as well. Again, the air around you is a homogeneous mixture, a solution of gases, one thing dissolved into another. So all of these represent the different ways that I can classify matter, and it's generally put under the heading of the organizational chart of matter. But again, what is it? And what it is kind of determines the properties it has, perhaps what you can do with it. And I hope that gives you a little bit of a jump start into this wonderful world of chemistry and how the bits and pieces work together. So, best of luck. See you next time.